Hello. Hello.
Yeah, hello, doctor.
Yeah, did you go through the previous session?
Hello.
Yeah, did you go through the previous
Uh,
session?
yeah, so yesterday I have just once revised, but I did not try any of programs.
Okay.
I'm moving from me and Chetu. We are moving from here, from our town to another city, so that's why we are a little bit busy.
Okay. You going to
Yeah,
some other state or some other city?
yeah, other state
Oh, okay.
from Texas to Georgia.
Georgia. How far it is?
It's far. I don't know, like 1,000 miles so or so, more
Oh.
than 1,000.
So your university is there only, or your university was in Texas?
My city was in Texas.
Okay. So now you're moving to Georgia, right?
Yeah,
Okay.
Atlanta.
Ah, yeah, Atlanta. Yeah, one of my friend is there.
Uh-huh,
Very
uh-huh.
cool there, right? I think I heard.
Yeah, it's kind of cool, I think so. Not, I don't know much about it.
Okay, okay. You're going for searching jobs there, or how is it? I mean,
Yeah, for searching job.
okay. So, like IT sectors, like jobs are there in more in this California, right? If I'm not wrong, I don't.
Yeah, California and also in this Atlanta, Georgia side, all in many major cities, we can have plenty of jobs.
So that is a little bit cheaper, or is it? I mean, this.
Yeah, it's cheaper. It's like,
Okay. Yeah, it's good. Like should not
yeah,
spend much till you get the job, right?
yeah. California is really very costly and more.
Yeah, that is Francisco,
Mm.
California. Yeah. Okay. So in thread we have done pretty much everything. Only two things is left. One is thread pooling, and another is one. I'll before that I'll close this one. So it's cover this next only. We'll cover today other things. So, yeah. So as I told you, there are two ways in which we could have uh, created a thread. One is like extending a thread class, and one is by implementing the enable. Okay, but the
Okay.
problem with those two is that I'll just open the older one. Uh, the run method, if you see here, run counter manager, run method, it returns the void. Okay, so
Mm-hmm.
whenever we used to start this thread, it calls this run method internally, right? So
Mm-hmm.
whenever it calls it and something happens, suppose some problem happens and it did not finish well, or I want to return something from here, that okay, my thread is getting executed, I won't be able to do that because here it's a void. Okay, so
Mm-hmm.
this void will return nothing, so I won't be able to track down whether my thread is getting executed properly or not. So
Mm-hmm.
there is a in Java there is a feature through which you can use the callable interface, and the callable interface will have the ability to return that value. I mean, whatever you want to return, suppose you want to return the string value or something, so here it's like default, it has to be void only, you can't do anything, and it does run something, and it finishes here. It never tells you what exactly you, suppose I want to return success, or I am running or something, I won't be able to do this for here. Okay,
Yeah.
so in order to achieve that that one, you need to create the callable interface. Using callable interface, what we can do, it will return the value that okay, I am getting executed, or I got executed. and so you need to override the callable interface. So let's do this. Implements callable, and you need to suppose I want to return a string. So I'll just do like this. We'll create implements callable, and this will be the return type of that. So instead of that void run, right, it will be like a
Mm-hmm.
string, and instead of run there is a method here is call. So if you can see here, so whatever you will give here, if you give here a string, the return type will be string. If you give here integer or
Okay.
boolean or something, it will be like this here. Okay, and
Mm-hmm.
this is the call method, just similar to this one, just similar to run. So instead of run, we need to write it here as call. Okay, and then it will return
Yeah.
some value. So return success, something like that. Okay, and we'll do. So I am running now. So whenever you create this one, it will you will get the uh, this string whenever you start that thread, right? So this is how I can try that. 1 second, I have to use the thread pooling self thread. Okay, so this is my main thread, which will be I will be creating the object and running it. Now this callable interface goes with thread pool only, because it will return some object which is a type of what I say future class. So I'll do you one thing, executor to service. Okay, so what it does is here, uh, in previous sessions, what we did is that we used to create the threads by our own, and number of, suppose I need 5 threads. So here, if I need 50 threads, I used to run a for loop, and I used to
Mm-hmm.
call 50 threads, and they used to call the run method and work on it. But in case of thread pooling, what happens is, uh, thread pool is just like here. If I need 5 threads, right? So here, what was that? If we need 50 threads, we created 1 to 50. But in this one, suppose we need 50 threads, we'll simply write it here as 50. So what exactly this does is, executor service is a class which is able to create the 50 threads. Okay, if you give whatever the number, if you give, it will create that many of threads, okay, internally. And
Uh-huh.
it's like a worker, just like, so if I write it here 50, that means you got 50 workers, and now you can assign the task to those workers. Okay, so suppose you have 200 factories to work on. In that, you can give these 50 workers to work. Okay, you go and work for those factories 200 tasks. So they will go one by one or two by two or something like that. They will go and finish their work. Once it finishes, it will go to the other one. Okay, so,
Okay.
suppose I have a 5 thread, and this callable interface inside that need to print some values. So So all the workers duty is to print from 1 to 5. Once it is done, it will come back and it will do the other printing. Okay, so I have created
Mm-hmm.
5 workers. All these 5 workers duty is to print 1 to 5. Okay, and now we need to create the number of threads whatever we want. So we will do one thing, to submit this to. Okay, so we need to create, suppose I want to print 1 to 5 50 times. Okay, so int I equal
Okay.
to 1 less than equals to 50 plus plus. So I will create the object of this callable interface example for 50
Mm-hmm.
times. So I'm creating this name as a task. Okay, so callable task I'm creating, task like 50 task I will be creating. So 50 times it should print 1 to 5 1 to 5 1 to 5, and 50 will be too much I think, so let's get it 10 times only. And we will submit this task to the so how we can execute this task. So I need to give this to the thread pool. So executor dot submit, and we'll submit this task. Okay, so at this point
Mm-hmm.
of time if I execute it, it will simply print me this 1 to, it will simply print say 1 to 5 1 to 5, and thread 1. So if you see here, the thread, it will maximum it can go to thread 5 only, it will never create the thread 6. All the work is done by the thread, so see, 1 is printed by thread pool 1, thread 1, and then thread 5, then thread 4, then thread 3, then thread 2, then value 2 is printed by, value 3 is printed by, again 2 was left back. So this thing, so if you are seeing 1 to 5 it is printing, every thread is like, how many threads are total if you see. So thread 1, 5 4 3
Five.
2, and yeah, so total 5 types of thread are
Yeah.
only are there, right? So all these
Uh-huh.
works, I mean, all these works means what the task is. The task is here to print 1 to 5. This is a one task, to print 1 to 5. So how many times they have printed? 10 times. So 10 times was
Yeah.
printed by how many threads? 5 threads. Okay, so
Mm-hmm.
it's not like one thread will print 2 times, it could be random, one thread could print 3 times also. Okay, so it depends,
Okay.
how the, it's like, I have given 10 jobs, 10 tasks to 5 people. Now one people is very fast, they can do 4 jobs also, they can print 4 times also. One is very
Mm-hmm.
slow, one can do only one time only. So it's like, once they finish their work, it will come back to the pool. So that's what the thread pool is all about. The thread will never die. Once you create it 5 threads, it will keep on in a runnable state, and one at a time, or parallelly, they will finish their jobs and come back. But here if you see, I'm not able to get the returned value what I want, right? I want this string value which is a success, right? So I want to print whether this is success or not. So what I will do is that I will print success only if it finishes its printing value as 5. Okay, so
Okay. Mm-hmm.
I'll int counter equal to 0, and every time it print, and I will create counter plus plus if counter is equal to 5. Okay, so
Uh-huh.
what I'm doing is that if they finishes the this one, then it will return success, else it will return that is still printing. Okay, because they did not
Mm-hmm.
finish it, so counter will finish. So for every thread, every task, there will be one counter, and if counter reaches to 5, it will return success, it will return the printing. So how we can get the hold of it? So once we execute this, right, it returns a future object, that this one, the value. So future of string it will return. So we will create one list of futures. So array list of futures, and we'll keep adding into the future list. So future list dot add future. So now this is holding the all the output of whatever the return type value they are giving, right? So it is
Mm-hmm.
returning those values in here. So what we need to do is that we need to print it once this is done. So let's get it printed. Or loop here. So we'll see. So it is returning those values. So what we can do is for each loop and future of string f colon future list, and we'll print it returned dot get. So let's print now. So if you can see here, whoever is finished, it is telling that they have finished, and few are like printing the returned value. Okay, so value is printed, and see returned value success. For these things, returned value success. Okay, so it's like everyone has finished it. By the time I'm printing, so see these things, I'll do one thing, I'll make it 100. Keep on executing very fast. So everyone is returning this return value success. So I'm assuming that the printing is done properly, and there is no
Uh-huh.
problem with that. So this is how you can track that your thread is executing properly. Fancy. So all these value,
Okay.
return the value. So wherever it is happening, right, it is a return success. So I will be able to know that my work is done properly. But in case of runnable and thread class, what we are using, we will never know that whether it has run properly or not. Suppose some exception would have occurred here. No, it would have returned me that exception. So just like here, return value is here, right? So one second. So callable interface. So here still exists and still printing. So imagine some problem happens here, right? And we need to do something. I'll say if counter is 5, that is okay. But here I'll write it if I just want to throw some exception. Okay, so
Mhm.
counter equals to 2.
ऑफिस जाए क्या हाँ
Hmm.
हाँ
Hmm.
क्यों
So new null pointer exception, and we need to handle it. So new and
बता दीजिए
okay. What I am doing, I'm intentionally just to the usage I'm trying to make you understand that what so just I am thinking that okay, whenever the counter reaches to 2, just throw one null pointer exception, and catch that and send it to them that okay, there was some exception when this was executing. Okay, so that we will be able to know. Otherwise, send it success, send it still printing, and this is how it will done. So let's run it. Didn't print anywhere. Exception. Um, if count request equals to 2, throw new exception. And why it is happening is because it is printing at the end. So when this threads finishes, right? So then
Mm-hmm.
it is printing. So this success, when the counter reaches to 5, once the thread is finishing, then only it is, that future is getting called. That's why it is everyone is returning success only. Everyone is returning
Okay.
success only. Okay. Anyhow, the usage, I'll check it how we can produce that problem. I don't know why it is not producing that problem. But the usage, what I want to teach is that whenever you need to return something, whether the job got executed success or still printing or some problem has happened, so it's very useful and handy to have a return type always. And as Runnable and Thread does not support, so we are bound to use this callable interface, and this is how you can use it. So the callable interface, just I'll recap it. So callable is string type of, I have put as a string. So wherever you are submitting this job, I mean you're calling it, you can simply call it using that, and it will return you a future object. So this future object, you can use it for the future purpose, and you can check it whether the this one was done properly or how is it. So you can print it, so whether return
Mm-hmm.
type is so this future, in fact you can do a few more things if you want. So future dot, if you say, you can check it whether that thread got completed or got executed or how is it. So is cancelled is there, is done is there. Okay, you can check it, all these things, whether it was is done. You can cancel that if you want, is cancelled is there, and one cancel will also, yeah. So cancel is also there. Suppose you have a requirement like, okay, you are running 10 threads, and all 10 threads should be get executed properly, and because of some problem your second thread got into some problem. So what you can do is that you will check it, that if there is any issue with any thread, you can cancel the rest of the threads, because your problem will not be resolved if any of the thread becomes problematic. So you can call this thread dot cancel, and this cancel, what it will do, that it will interrupt the rest of the threads. Suppose you have 10 threads to make a transaction from one bank account to another bank account. So all these transactions should completed, like, okay, update the account holders in which the money is debited, update the account holders in which the money is credited, update your passport, passbook, update your internet banking, update all these things. So suppose there are 10 updates which is required to make a transaction. Okay, and you are doing that updation using those 10 threads. And just imagine, just assume that one of the thread, suppose your vendor, like your the account in which the money should be credited is down, the website or application is down. So what will happen, you have got the money from the previous bank, right? I mean the first bank, and you need to put in second bank. So you cannot keep money with you, right? Either transaction has to be atomic, either it has to go this side or that side. It should not be lying in between. It should never be
Mm-hmm.
like the money got debited from one account and it never got credited in that another account. It can never happen, because your transactions APIs or transaction process should be written in such a way that if 100 rupees got debited from your account, it has to credit it in another account, either mistakenly in some other account, but it has to get into the some other account. It cannot get a hold in between. Okay, so
Okay.
just imagine you got the money, you debited the money from one bank, and by the time you could
Mm-hmm.
have credited that amount to the other bank, the application was down. Okay, the
Okay.
bank in which
Uh-huh.
you have to credit is down. So what will happen, what you will do, you will revert back. correct? You will roll
Yeah.
back to the original, right? You will refund the money to the account holder from which they debited by saying that transaction was unsuccessful because of some failure and so and so. So
Mm-hmm.
imagine it's not about transferring the money from 100 to another bank to this bank. It's about other things also, like you need to update the DB, you need to update the account balance, you need to update the internet banking details, you need to update the transactions salary summary and all these things, other things. So will you do
Mm-hmm.
all these operations if your transaction fails? No, right?
No.
So
Mm-hmm.
this is where this future is coming to the picture. So if I have the future list, and just imagine that I have 100 tasks to do. So just like 10 tasks to do a transaction. Okay. So first two got
Okay.
completed successfully. I debited the amount, and I have updated their the first banks that okay, your amount is debited. Two things I did. Third thing, when I went and I'm trying to do it, is that I'm updating the other bank's detail that got failed. So as soon as it gets failed, I will be iterating over here, and I will keep checking like this. So is done. Okay. So if it says it fails or exception
Mm-hmm.
it gives, what I will do is that I will do f dot cancel. I will say, okay, do not proceed
Okay.
because I am going to refund the money. Do not proceed with the internet banking updation. Do not proceed with no monthly report and all this. Do not do anything. Cancel all the jobs. Get back to the original point. Okay. So this is where
Okay.
the futures come into the picture. So you will be having the hold of
Mm-hmm.
the jobs which didn't even run. I mean, in future it can run. So those things you can handle from here. Okay.
Mm-hmm.
So this is the importance of using the future as well as using the uh, interface callable. So future you can use it only when you are using callable. So that is quite handy and useful if you're using this callable interface where you are getting the output like okay, whether the transaction was successful or failed or anything. Okay. So this
Mm-hmm.
was about future and this thread pool, how it is useful than your normal thread creation. I could have done is by using, creating 5 threads and worked it right. Instead of that, I went for this
Yeah.
thread pool is because there is one and more important thing is that if suppose here I am showing you one example like okay, create 50 threads in the previous example, this account example I'm telling you. So I have
Mm-hmm.
50 threads. Right now I can limit it to 50, but imagine about the real time application where 1 lakh user or 2 lakh users can log into your system, and you will have no limit over threads. You cannot put like this that okay, less than greater than 50 and create that many of threads. It could reach to 1 lakh or 2 lakh number of threads. An operating system has a limit of 32,000 threads only at a time it can create. Okay. If you try to create
Okay.
more than 32,000 threads, your application will crash. Okay.
Mm-hmm.
So if
Yeah.
you're writing like this, like okay, whatever the request comes, create a thread for that. Now imagine 1
Mm-hmm.
lakh user has come and 1 lakh has thread has been created, your system will crash. So in order to handle that, how you can limit your number of threads is that you need to use the thread pooling. In this case you cannot limit it. Right now I am using 50, but I will not be using this for loop at all for my real time application. There, the thread will be created whenever the request comes. So 1 lakh request comes, I will create 1 lakh threads and it will go, it will crash. I cannot use for such things this thread. Okay. So what I will do is that I'll create an executor service which will create like suppose 50 threads or 500 threads. That's all. I will not create more than 500 threads. And suppose 1 lakh request has come. Okay. I need to create 1 lakh threads. I will not create at one instance. Okay. What I will do is that I have 500 threads. I know that means I have 500 workers. Okay. And I have got a request of 1 lakh service, and I need to do it with the help of 500 workers. Okay. What I will do, I'll assign one job to all 500 workers. So at one point
Mm-hmm.
of time, how many jobs I can do? 500 jobs, right?
500
Once
jobs. Yeah.
500 jobs finishes, I'll assign again 111 to everyone. Again
Everyone.
1000 will done. Again 1500, and like this, it will be done. So I never created more than 500 threads in my application, that is for sure, right? So it will
Yeah.
never crash. Okay,
Mm-hmm.
so if 2 lakhs or 20 lakhs or 1 million or billion request comes, my application might go slow. That's why, when the too many requests comes to the, applications, you might see the web application becomes very slow. The page opening very slowly, and all this happens.
Yeah.
You might have experienced
Uh-huh.
them, right? Why it
Yeah.
happens
Yeah.
is that they use Threadpool for such things, and they cannot create that many of threads. How many requests is coming? They have a limitations of 50 or 500 or 100 threads, and
Mm-hmm.
they keep on, executing. The once it is done, it will remove that from the queue again, get the new fresh jobs and do it. So in that case, it will never crash, and it will work. So that is the
Okay.
main benefit of using the thread pool. And this is the
Uh-huh.
one line of code which, handles everything. So you create that many of threads, and
Mm-hmm.
in order to execute that, you only need to do this submit. So you simply do executor or dot submit, and this task is nothing but object of callable. So you can put a object of thread also, there is no problem. Okay, it's not necessary that executor service, the thread pool, goes with callable interface only. You can even put thread class or thread object as well.
Mm-hmm.
So this is the, uses of thread executor service. Got it right?
Yeah, got it.
So do one thing. I want to check that. So you do
Uh-huh.
it. You do the, you write a program. Tomorrow you show it to me. This executor
Yeah,
service,
okay.
you create executor service, and instead of
Uh-huh.
putting this, task which is a callable, don't put callable.
Uh-huh.
Put thread and runnable interfaces in that. And just like, I am printing 1 to 50 or 1 to 10, just print 10 times and just send it to me. I'll just check it whether got the idea of this or not. Okay, so once
Yeah,
the
yeah.
time,
Yeah, okay.
instead of callable, do not put callable, put, runnable, or other thread
Runnable.
classes and all this, just like account only, right? Use that account.
Mm-hmm. Yeah.
So here I'm using,
Yeah.
in main app, I'm creating 1 to 50, right?
Uh-huh.
Do not create 1 to 50.
Yeah.
So just like here, create this executor service,
Mm-hmm.
uh, executor service, and instead of, doing this start,
Mm-hmm.
do this. I'll just remove this after doing this. So executors dot let it here 5. So only 5 thread I am creating.
Okay.
And instead of this 50 times, what I will do is executor service dot submit and
Mm-hmm.
user thread. Or there is one more method. If you don't expect the future, you can do the execute. So the difference between execute and submit is that execute does not return anything. So as I am not expecting also, because I am not using callable, so in this case you see that it is returning this string, right? That's why I
Mm-hmm.
put here executors dot submit. So submit, if you see the return type, it is showing that it is returning the future of string, correct? So I am
Yeah.
the return type. But in case of account manager app, I am not expecting anything, so I will just simply do the execute. So it will do the same thing.
Mm-hmm.
Okay, see, it is withdrawing the money and doing all this stuff. Okay,
Yeah.
so
Good.
this is how you can use it. I'll not push this code. I want you to write it end to end, account
Mm-hmm.
manager. Okay, so
Yeah, okay.
just whenever you have time, when you are shifting, just close.
Uh, 13th, on 13th.
Okay, so the
The on
classes will be